Your Azure VM is running. Everything looks fine. Then a server rack fails in the Microsoft data center and your application goes completely offline. That scenario happens to companies every day, not because Azure is unreliable, but because they deployed their VMs with no availability strategy. In this video, I am going to show you the 3 ways Azure gives you high availability for virtual machines and exactly how to achieve the 99.99% SLA Microsoft guarantees for production workloads. We are covering availability zones, availability sets, and Azure Virtual Machine Scale Sets, what each one means, when to use each one, and how to set them up in the portal step by step. This covers a major chunk of the AZ-104 compute section. Whether you are studying for the exam, deploying production workloads, or just trying to understand what these options actually do, this video is for you. I'm Jai from Jai CloudSec. Let's build. Let me start with the most important thing. If you deploy a single Azure VM and nothing else, Microsoft gives you zero SLA, no uptime guarantee, none. That means if the underlying hardware fails, your VM goes down and Microsoft owes you nothing in terms of the service level agreement. This is actually documented in Microsoft's own terms. The moment you add availability features, zones, sets, or scale sets, you jump to either 99.95% or 99.99% SLA. That is the difference between having a legal guarantee from Microsoft and having nothing. In production, this matters. A 99.99% SLA means your app can only be down for about 52 minutes per year. 99.95% means about 4.5 hours. The right choice depends on your workload. Exam tip: single VM equals no SLA. Any availability option equals SLA. This exact point is tested on AZ-104. Know the SLA numbers: 99.95% for availability sets, 99.99% for availability zones, and VMSS. Azure gives you 3 options for VM high availability. Let me give you the quick summary before we go deep on each one. Option 1, availability zones. Physically separate data centers within one Azure region. If one data center loses power, your app keeps running in another. 99.99% SLA. This is the preferred option for all new workloads. Option 2, availability sets. Your VMs spread across different racks and maintenance groups within the same data center. Protects against hardware failure and planned maintenance. 99.95% SLA. Used mainly where zones are not supported. Option 3, Azure Virtual Machine Scale Sets. A group of identical automatically scaling VMs managed as one unit. Can span multiple availability zones. Automatically adds or removes VMs based on demand. 99.99% SLA. This is what Microsoft now officially recommends for high availability. We are going to cover all 3 in depth, and then I will show you exactly how to create each one in the portal. Let's start with availability zones. Availability zones. Let me explain exactly what these are. An availability zone is a physically separate location within an Azure region. Think of it like having your business running in 3 separate buildings in the same city, each one with its own power supply, its own cooling, and its own network connection. If one building loses power, the other 2 keep serving your customers. Nobody notices anything happened. Every Azure region that supports availability zones has at least 3 zones. Each one is genuinely physically separate. Separate power, separate network, separate cooling. Microsoft connects them with high performance networking with a round trip latency of under 2 milliseconds, so they behave like one environment to your application. When you deploy a VM to Zone 1 and another VM to Zone 2, if Zone 1's entire data center goes down, Zone 2 keeps running. Microsoft's SLA for this configuration is 99.99%, the highest availability guarantee Azure offers for virtual machines. Exam tip: deploy VMs to at least 2 different zones, not both in the same zone. If both VMs are in Zone 1, you lose both when Zone 1 fails. Spread across Zones 1 and 2 minimum. AZ-104 tests this. Availability sets. These work differently from zones, and it is important to understand why. An availability set is a logical grouping of VMs within a single data center. There is no cross-data center protection here. Everything is in one building. What it protects you against is hardware failures within that building and planned maintenance events. It does this through two concepts: fault domains and update domains. A fault domain is a separate physical rack with its own power supply and network switch. Azure places your VMs across different fault domains, so if one rack loses power, the VMs on the other rack keep running. You can have up to 3 fault domains in an availability set. An update domain is a group of VMs that Microsoft reboots at the same time during planned maintenance. Azure places your VMs across different update domains, so when Microsoft reboots update domain 1 for maintenance, update domain 2 is still running. You can have up to 20 update domains. The result is 99.95% SLA, still a strong guarantee, but less than zones because a full data center failure would take down everything in the set. Production warning: availability sets are now considered legacy. Microsoft recommends availability zones for all new workloads. Use availability sets only if you are in a region that does not support zones. Exam tip: availability set must be created before the VMs. You cannot add an existing VM to an availability set after creation. This is the number one mistake in AZ-104 labs. So, what is the difference between availability zones versus availability sets? Let me put them side by side so you can see exactly when to use each one. Availability zones: 99.99% SLA. Cross data center protection. Works in most Azure regions. Microsoft preferred for new deployments. Availability sets: 99.95% SLA. Protection within one data center only. Works in all Azure regions, including older ones without zone support. Free. You only pay for the VM instances. The decision is simple. If your region supports availability zones, use zones. If it does not, use availability sets. And if you need automatic scaling on top of high availability, use scale sets, which we cover next. Azure Virtual Machine Scale Sets. This is the most powerful of the 3 options, and as of the latest Microsoft documentation, it is the officially recommended approach for high availability. An Azure Virtual Machine Scale Set lets you deploy and manage a group of identical virtual machines as a single unit. Azure handles all the orchestration. You define the rules, Azure does the work. Here is the key capability that makes scale sets different: autoscaling. You define a minimum and maximum number of VMs. You set a scale out rule. For example, if CPU usage exceeds 80% for 5 minutes, add 1 VM. You set a scale in rule. If CPU drops below 20%, remove 1 VM. Azure monitors, decides, and acts automatically. You pay only for the VMs that are actually running. Scale sets can also span multiple availability zones, so you get the highest possible availability combined with automatic scaling. This is the combination Microsoft recommends for production enterprise workloads. There are two orchestration modes: flexible, which supports different VM types and is the recommended mode, and uniform, which requires all instances to be identical. For most use cases, flexible is the right choice. Exam tip: VMSS flexible orchestration is Microsoft's recommended HA solution. Uniform is for identical instant workloads. Scale out adds VMs when CPU is high. Scale in removes when low. In the Azure portal, go to the virtual machines. Click Create, then Azure Virtual Machine. A new configuration window opens. Subscription, select your subscription. Mine says Pay As You Go. Resource group, RG Demo Lab. Virtual machine name, Zone VM01. Region, Central US, or the region closest to you. Under Availability Options, click the drop-down and change it to Availability Zone. A second drop-down now appears directly below it, also called Availability Zone. This second drop-down is where you select the actual zone. Select Zone 1. This tells Azure which physical data center to deploy this VM into. VM image, Windows Server 2025 data center. VM size, standard_B2S. For administrator username, type Azure admin. Set a strong password. Check the license and agree to it. Click Next. For OS disk, leave all default. Click Next. On the Networking tab, under Inbound Port Rules, select Allow Selected Ports. Choose RDP port 3389 for this lab demo. Remember, in production, you would close this and use Bastion instead, as we covered in the previous video. Click Review and Create. Once Azure validates, click Create. Deployment takes few minutes. To make this properly zone redundant, create a second identical VM and select Zone 2. With an Azure load balancer in front of both VMs, you now have 99.99% SLA across two physically separate data centers. Go to the virtual machine, and on the overview page, you can check availability zone for both the VM. I have created both the VM and will show you on VM how to verify the configuration. For VM1, it will say Zone 1. For VM2, it will say Zone 2. Exam tip: deploy VM1 to Zone 1 and VM2 to Zone 2. Both behind a load balancer equals 99.99% SLA. Single VM in one zone equals no SLA. AZ-104 tests this distinction. For availability sets, and this is absolutely critical, you must create the set first before creating any VMs. You cannot add an existing VM to a set after it has been created. The VM must be assigned during creation. In the Azure portal, search for availability sets at the top. Click Availability Sets, then Create. Subscription, select yours. Mine is Pay As You Go. Resource group, RG Demo Lab. MAME, AFSET Lab. Region, North Central US. Must match the region you will deploy your VMs in. Fault domains, leave at 2. This means your VMs will be placed on 2 separate physical server racks, each with its own power supply. If one rack loses power, only the VMs on that rack go down. Update domains, leave at 5. This staggers planned Microsoft maintenance, so only one group of VMs restarts at a time. Critical. These numbers cannot be changed after the set is created. Set them correctly now. Click Review and Create. Once validated, click Create. The set deploys in seconds. It is just a logical container. No VMs yet. Now, we create the first VM and assign it to this set. Go to Virtual Machines, then create Azure Virtual Machine. On the Basics tab, under Availability Options, select Availability Set. A drop-down appears. Select ABSET Lab. Complete the rest: image, size, credentials, networking. Click Review and Create. I have already deployed both the VM for this recording using the same steps. Assign it to the same ABSET Lab. Azure automatically places this VM in a different fault domain and update domain from VM1. Once both VMs are deployed, go to your availability set. You will see both VMs listed. VM1 will show fault domain 0, and VM2 will show fault domain 1, confirming they are on separate physical racks. This is the proof the set is working correctly. Production warning. You cannot add a VM to an availability set after it has been created. The set must exist first, and the VM must be assigned during creation. This is the number one mistake in AZ-104 labs. Exam tip: availability set must exist before VMs. Max 3 fault domains, max 20 update domains, 99.95% SLA. Sets equals same data center only. Zones, cross-datacenter. All tested on AZ-104. Now, let's create the scale set. In the Azure portal, search Virtual Machine Scale Sets and go to the Virtual Machine Scale Set. Click Create. A new configuration window opens. Subscription. Select your subscription. Resource group, RG Demo Lab. Name, VMSS Lab 01. Region, Central US. Scroll to the Availability Zone section. Tick Zone 1, Zone 2, and Zone 3. This spreads your VM instances across all 3 data centers for maximum redundancy. Orchestration mode, flexible. This is the recommended mode in 2026. In the scaling section during creation, set initial instance count to 2. Leave the scaling policy at manual for now. We will configure custom autoscaling after deployment. Image, Windows Server 2025 data center. Size, standard B2s for this lab. Click next through disks, networking, and health tabs, leaving defaults. Click Review and Create. Deployment takes few minutes. Once your scale set has deployed, open it. Now we configure the auto-scaling rules. Go to Virtual Machine Scale Set and open the scale set which was created. In your deployed scale set, look at the left menu. Click Scaling. You will see the current scaling policy is set to manual. Click Custom Autoscale to switch to rule-based scaling. Give a name or leave default. Resource group, RG Demo Lab. Predictive Autoscale, forecast only. Click on the link to learn more in depth on how to autoscale conditions. For scale mode, change it to scale based on metrics. Click Add a rule. Metric name, CPU percentage. Operator greater than. Threshold 80. Duration 5 minutes. Action, increase count by 1. Click Add. This rule means if average CPU across all instances exceeds 80% for 5 minutes, Azure adds one more VM automatically. Click Add a rule again. Metric name, CPU percentage. Operator, less than. Threshold, 20. Duration, 5 minutes. Action, decrease count by 1. Click Add. This rule means if average CPU drops below 20% for 5 minutes, Azure removes one VM, saving you cost. Click Save at the top of the scaling page. Your autoscale rules are now active. You can create different rules based on your requirement. Click Instances in the left menu. You will see 2 VM instances, each showing a different availability zone. This confirms your scale set is zone redundant. If Zone 1 fails, the instance in Zone 2 keeps running. And if traffic spikes, Azure adds VMs automatically up to your maximum of 5. Exam tip: VMSS flexible orchestration equals recommended. Uniform equals identical instances only. Autoscale uses Azure Monitor metrics. Scale out, add VMs. Scale in, remove VMs. All tested on AZ-104. Before I recap, let me give you the quick decision guide for when you face this choice in an exam or in real life. New production workload, region supports zones, use availability zones. Region does not support zones, use availability sets. Need auto scaling on top of availability? Use Azure Virtual Machine Scale Sets. Need the absolute highest SLA plus auto scaling plus flexibility? Use VM Scale Sets deployed across availability zones. Study or lab environment? No infrastructure redundancy required. You do not need the cost or complexity. Let's recap everything we just covered. Availability zones, physically separate data centers, 99.99% SLA, cross-datacenter protection, preferred for all new workloads. Availability sets, same data center, 99.95% SLA, fault domains protect against hardware failure, update domains protect during planned maintenance, and the availability set must be created before any VMs. Azure Virtual Machine Scale Sets, group of identical auto-scaling VMs, can span zones, 99.99% SLA, configure auto-scale rules after deployment, Microsoft's officially recommended HA solution, and the single most important thing to remember for AZ-104, a single VM with no availability option has zero SLA from Microsoft. Always use one of these 3 options for any production deployment. And that is Azure VM availability, availability zones, availability sets, and VM scale sets, concepts, comparison, and full portal lab. If you are new here, the previous videos in this series cover Azure free account setup and Azure VM creation with Bastion. Links are in the description. In the next video, we are going into Azure networking deep dive, VNet peering, NSG rules, and private endpoints. If you are deploying Azure for your organization and need hands-on help, the link in the description connects you with me directly at Jai CloudSec. If this video helped you, hit subscribe. New Azure content every week. I'm Jai from Jai CloudSec.